Okay, we're going to move on to type 3. Have a tendency to be a little bit more complicated. What you have here is a square root on one, and you probably have an x on the other side. And it doesn't really matter if that x is under a radical or not. The reason these are going to be more complicated is because we're going to end up with an x squared. So again, you could rewrite this one, remember, as the square root of 8x is equal to x. This problem written is the same as this problem. I'm going to work it with the 1/2 exponent rather than the radical. Each side is, or the radical is isolated, it's by itself, so there's nothing for me to do but to raise both sides to the second power. So I'm going to square both sides. And on this side, the 1/2 and the 2 are going to reduce out, leaving the exponent to be 1. And that leaves the 8x by itself. And here we end up with an x squared because I had to square that side of the equal sign as well. And so I ended up with a quadratic. And that's why this becomes a little bit more complicated because, as you guys know, solving quadratics requires factoring, and that's a struggle that some of you still have. So anytime you have to factor a quadratic, you have to set it equal to 0. So I'm going to move the 8x to the other side of the equal sign with the x squared. And now this is not a trinomial, it is a binomial. It's a binomial with a GCF, so I'm going to factor out that x. And that's going to leave me x minus 8. And now I'm going to set each one of them equal to 0. That's called the zero product property. I'm going to set each one of them equal to 0. X equals 0 is already solved. X minus 8 can be solved by adding 8 to both sides. So we get 2 answers. I'm going to check both of them because, especially when I deal with quadratics and I get 2 answers, they do need to be checked and make sure that they do not cause us to get an imaginary number. When you plug in 0 right here, we have to take the square root of 0. That's okay. When we plug in 0 on this side, we just get 0. We plug in 8 on this side, we get a positive number. And when we plug in 8 over here, it's a positive number. So both of those answers are correct. Still a type 3. We have a square root on one side of the equal sign with an x underneath it. On this side, we have an x and a 2, so we have a binomial. It is going to be one that results in a quadratic, and this one's going to be just a smidge bit more complicated because it's not just going to be a GCF, it's going to be a trinomial that has to be factored. The majority of the problems that you're going to be required to do are going to be of the type 1 and type 2. So as long as you can do type 1 and type 2, you will be able to pass this assignment. If you want to make an A on this assignment or this topic, then you will need to be able to do at least this part of the type 3 problems. Maybe a simple one like this where you do have to at least factor out a GCF, or maybe one where you have to factor a trinomial. I'm even going to give you a bonus type problem, which is going to be like extra. But again, you won't be required to do the bonus one. When I get there, I'll explain to you what I mean. So this problem right here, we have the radical is isolated, so we are ready to square both sides. So you square this side and you square that side. And the square cancels that with the square root, leaving us 2x plus 3. On this side, oh my gosh, if you're not very careful, you're going to just distribute that 2, and that will be wrong. The answer to x plus 2 squared is not x squared plus 4, and that's what everybody's going to put. Remember, x plus 2 squared means x plus 2 times x plus 2. You have to do FOIL and combine like terms. So you get x squared, you get 4x, and then you get 4. So what's going to happen is people are going to forget this middle term because you get x times x, you get x squared, that gives you 2x, that gives you 2x, that gives you 4. You put the two 2x's together and get 4x. There is a faster way to do it. You can square the x squared, get the x squared, multiply the x times the 2 together, and then double it. That will give you the 4x, and then square the 2. I'll model that again for you. Same thing as a while ago. We have to set this equal to 0. So I'm going to subtract 2x over here and add 3 so that I will get subtract the 2x right here, subtract the 3, so this side will be 0, but I have to do the same thing to this side, and I'm going to put them where the like terms line up. So I'm going to subtract the 2x from the 4x, and I'm going to subtract the 3 from the 9. And on this side, I'm left with 0, and this side I have x squared plus 2x, because a positive 4 and a negative 2 combined together give me a positive 2, and that'll give me a positive 6. And now I've got to factor this. This should be an easy factoring problem. Two numbers that multiply together to give me 6, that add to give me 2. And it may not be, may have to do the quadratic formula, but two numbers that multiply together give me 6, that are 6 and 1 and 2 and 3, and neither one of those add together to give me a 2. So hold on, let me see what is expected of us. Quadratic formula, or did I make a mistake? Just hold on real quick. Okay, I found my mistake. That's not a 9, it's a 4. And the reason that I knew to look, my 4s do go together to end up looking like 9s. There's nothing wrong with having to solve one of these by using the quadratic formula. I just know that usually we pick problems that can be factored because we're not trying to make the answer something that's so complicated that it's a hard problem to work. So I was expecting this to be factorable, and I was right. It should have been factorable. My 4 ended up looking like a 9. So when you subtract 3 from both sides, you end up with 1. Now this I recognize as a perfect square. Two numbers you can multiply together to give you 1, that add to give you 2. Factors of 1 that have a sum of 2. Factors of 1 are there, you only have one choice. 1 times 1 gives you 1, and 1 plus 1 give you 2. So the two factors here are x plus 1 times x plus 1. Of course, that can be rewritten as x plus 1 squared. You set that equal to 0, and you solve it, and your answer ends up being -1. Now, if you plug in, you got to go back and check. You plug in -1 right here. Well, that one, it doesn't matter because it's not underneath the radical. But if you plug it in right here, 2 times -1 is -2. -2 plus 3 is a positive number. So x equal -1 is absolutely your answer. All right, this next example is still a type 3, but it's going to be the one where it's a bonus. And the reason that this is a bonus, meaning I won't require you to do one of these on a test, but I will put one of these as a bonus on the test. It's a little extra, and the reason it's extra is because you're actually going to end up having to square both sides twice. So again, it's impossible for us to isolate both radicals. This square root of a plus 9, that one's isolated, but over here we've got a radical -1. Well, the only thing we can do to make that one go away would be to add 1 to both sides. We add 1 over here, the 1's cancel out or add out, but over here then we would have +1 on the end of that one, and it would be the same problem that we had. So we're not able to isolate the radical. So we're going to have to go ahead and square both sides. Now that means that we've got to multiply this binomial, the square root -1, times itself. The square root of a, we're going to have to do the square root of a minus 1 times the square root of a minus 1. So you have to do FOIL or double distribution or whatever. The square root of a times the square root of a, that just becomes a, because it becomes the square root of a squared, and then they cancel out. The square root of a times -1 is negative square root of a. -1 times a is another square root of a. And then -1 times -1 is +1. So I did these two together and got a. I did these two together and got negative square root of a. Got this one. I did these two together. I got another one of those. And then I did these two together and got the plus 1. And now these two I can combine like terms. So when I square that, I get a minus 2 of those plus 1. So on this side, my radical and my square cancel out. I'm left with a plus 9. And on this side, I'm left with a minus 2 square roots of a plus 1. Now this is where I said we're going to have to do it's like having to do the problem again because we still have a radical in it. And this time we should be able to isolate the radical. So I'm going to try to get this radical all by itself. So that means I'm going to do, I got to get rid of this a, I've got to get rid of the negative 2, and I've got to get rid of the 1. It doesn't really matter which ones you get rid of first, but let's start by doing minus 1. Minus 1, minus 1. So we're left with a minus 2 root a. That adds to 0. That leaves me 8. And then that leaves me with an a. I need to get rid of the a. It doesn't matter. I can move this a over here. I can move this a over here. I need to get rid of one of them. They're both positive. So if I decide to do minus a right here, then I have to do minus a right here, and they add out. So I'm left with 8 equals negative 2 root a. That says negative 2 times a. Negative 2 times the square root of a. So I've got to undo that multiplication. So I'm going to divide both sides by a. I get the square root of a is equal to negative 4. Now my radical is isolated, so I got to square both sides again. And then that leaves me negative 4 squared is 16, and that leaves me square root. So I got the answer A. I do need to check, and I actually need to check more than just to see, because if I plug in plug in 16 right there, I get a positive number. Plug in 16 right there, I get a positive number. So I don't have to worry about an extraneous root, but I do have to worry about no solution. So what's going to happen is, and this happens anytime we end up squaring a negative number, we get a solution algebraically, but graphically what's happening is like, let's see, one of these things looks like this. One of these graphs look like this. The other graph looks maybe something like this, and they actually never intersect. We'll go, if I have time, we'll go look and see what it is. But what happens is when you plug in 16, you get 16 plus 9, and that's equal to 16 minus 1. 16 plus 9 is 25, and then the square root of 16 is 4. And the square root of 25 is 5. So you end up with 5 equals 3. And that is not a true statement. So this answer is not a solution. So there is no solution because that was the only answer that we got. So this problem actually, after all of that work, came out to be no solution.